Now in this video, we're going to go over the second piece of the puzzle out of 3 and find horizontal and oblique or slant asymptotes. And to be able to find these, you want to compare the degree in the numerator, which we will refer to as n, and the degree in the denominator, which we will refer to as m. And there are 4 different things that can happen. So case 1, if the degree in the numerator is equal to the degree in the denominator, then the horizontal asymptote is the ratio of the leading coefficients. So for example, this is my function here. And notice I have 9x squared plus, and I don't know what's happening after it because it doesn't really matter. And then we have 3x squared plus, again, it doesn't really matter what's happening after. I'm just looking at these leading terms. Because x squared is my highest exponent in the numerator, that is my n. And because x squared is also my highest degree, or my highest exponent in the denominator, that's what we consider m. So when I'm comparing n and m, they are equal to each other. And so when that happens, we take the ratio of the leading coefficients. So we have 9 over 3. And so therefore, my horizontal asymptote is at y equals 3. Case 2, if the degree in the numerator is less than the degree in the denominator, then the horizontal asymptote is y equals 0. There's no solving, there's no looking for other things. It's just simply every time y equals 0. So here I have 8x to the 5th plus, and it doesn't matter what happens after. Because that x to the 5th is my highest exponent, that makes my degree up here n, over 7x to the 9th plus, and I don't know what's happening after it, but again, since the 9th is my highest exponent, that makes the degree of the numerator m9. So when I'm comparing, we have less on the numerator than in the denominator. And so when that happens, my horizontal asymptote is at y equals 0. Case 3, if the degree in the numerator is 2 plus more than that of the degree in the denominator, then there is not a horizontal or oblique asymptote. So here my n is 6, since that's the highest exponent. My m is 3, since that's the highest exponent. So here then we have no horizontal or oblique asymptotes, because we have at least 2 more than in the top than in the bottom. We have 3 more than, so it meets that criteria. So these first 3 cases are all very straightforward, very easy. If the m and n are equal, use the ratio. If you have less in the top than in the bottom, it's y equals 0. If you have more in the top than in the bottom, then we have no horizontal or oblique. But case 4 will have a little bit more work. Case 4 says if the degree in the numerator is exactly 1 more than the denominator, then use long division to find the linear oblique asymptote. Okay, so even though it says long division, I'm only going to use long division if I have to. Here, if this is what I am dividing, and I'm dividing by an x minus 2, do I have to use long division? Okay, we do not. This is a good one for synthetic. So we'll pull the 2 out. If you set that equal to 0, it's going to equal 2. So we'll pull 2 out. And then write your coefficients. You've got x squared, x 4, so I don't need any zeros here. So this is 2, -3, and 4. We will bring this first one down and then multiply, add till the end. So multiply to get 4, add to get 1, multiply to get 2, add to get 6. Now the 6 is my remainder, and I actually do not need it. All I need is these two here. What I'm wanting to do is put these into my y equals mx plus b form. And so this right here is my constant, that's my b, and this is my x, there's my m. So my linear oblique asymptote is at y equals 2x plus 1. Now, these aren't all going to be good candidates for synthetic. So let's quickly review our long division right here for when we need it. We will put whatever we are dividing by on the outside. And then just like I didn't have to put any zeros here, I don't need to put any zeros here because again, it's not skipping any place values. You got x squared, x constant. So that's going to go all under here. And now divide. We're going to divide the first term by the first term. So 2x squared divided by x gives me 2x. Multiply that back. 2x times x is 2x squared. 2x times -2 is a positive 4x. And just kidding, it's a negative 4x. So now we will subtract all of it. Put it in parentheses, subtracting everything. So 2 minus 2 cancels. Here we have -3 minus a -4. So minus negative becomes plus. So -3 plus 4 is x. We really don't need to bring down that 4, but we will just for sake values. And so now I'll divide this x by x here to get 1. And because I don't need this remainder, I'm done and I can stop. Here is my mx plus b form. So that tells me my oblique asymptote is at y equals 2x plus 1. Okay, so even though we have to use long division, it's not that bad since it's shorter, since I don't care about what the remainder is down here. Okay, so open up your book. You want to put this page on the left side so you can look at all of your cases. And now we will go over example 2, finding all horizontal or oblique asymptotes. Okay, but open up your booklet if you usually fold it back so that you can see the left side of the page along with this one here. So what we're doing is comparing our n and our m. So let's state what n and m are. N up here is the 7. My m down here is that 3. It's the highest exponent. So here, let's just decide which case of the 4 that this meets. Because n is 7 and m is 3, we have a case 3 where the degree in the numerator is 2 plus more than the degree in the denominator. And when I have a case 3, we have no horizontal or oblique. There is not any. So my answer here is no horizontal asymptotes or oblique asymptotes. Okay, on the top here, what is my n? Well, that's the same as x to the first. So n is 1. And what is my m? That's also the same as x to the first. So which case is this? The numerator is equal to the denominator. We have a case 1. And case 1 states that the horizontal asymptote is the ratio of the leading coefficients. So the leading coefficient is 2 over 1. We have a horizontal asymptote at y equals 2. On C, my n is 2. My m is 1. This one here is which case? This one is equal. This is the numerator is less than. The numerator is 2 more than. It is more than, but only 1 more than. 1 more than is case 4. Case 4 says we need to use long division to find the oblique asymptote. Do I have to use long division here though? No, this is a good candidate for synthetic. So if you set this equal to 0, we're going to pull out a -3. And then look if you need any placeholders. You have x squared, no x, and 12. So yes, we do. We need 3, 0, and then -12. So bring down the first one, then multiply, add till the end. So -9 and -9. And actually, I can stop right there. I don't really care about that remainder portion. Here is my constant and my x. So this tells me my oblique asymptote was at y equals 3x minus 9. Okay, on D, compare your n and your m. Okay, n might be a little bit tricky. M is to the first. So if x is to the first power, if I have no x's at all, then that means I have an n of 0. That would be the same as 1 times x to the 0 power. So this right here means that we have case number what? This is a case number 2. The numerator is less than the denominator. And when that happens, we just simply have a horizontal asymptote at y equals 0. Okay, why don't you try pausing the video and seeing if you can do E and F on your own. Okay, hopefully you've paused the video, so let's check your answers. N is 2, since that's the highest exponent, and my M is also 2. So that would have been a case number 1. In case number 1, since they're equal, says as the horizontal asymptote is the ratio of the leading coefficients. My leading coefficient is the coefficient in front of those x squareds, not that 5 right here. So it means we have y equals -8 over 8, which means we have a horizontal asymptote at y equals -1. And then lastly, my n is 4, my m is 3. This is a case number 4. In case number 4, since we have to use long division to find the oblique asymptote, do I need long division here? Yes. You can only use synthetic when it's x plus or minus a number. Because of that x cubed and even that x squared, you cannot use synthetic here. So I'm going to bring this on the outside, what we're dividing by. And then we're going to need several placeholders here. My x to the fourth goes first. I have no x cubed. So we need to put a 0 x cubed. We have a negative x squared. I have no x and I have no constant. So we needed to add 3 zeros here. So start dividing. 3x to the fourth divided by x cubed is 3x. Distribute that back. 3x times x cubed is 3x to the fourth. 3x times a negative x squared is negative 3x cubed. And 3x times 1 is 3x. Don't put that under your x squared. That goes under your x column. So we're going to subtract everything. 3 minus 3 cancels. How many x cubes do I have? Well, hopefully you've already done this. This is 0 minus a negative. Minus a negative becomes a positive 3. Bring this down. And then how many x's do I have? This is 0 minus 3. So we have negative 3x. And then we'll bring down our plus 0. So now our last step is just to divide this one last time. 3x cubed divided by x cubed is 3. There is my mx plus b. So my oblique asymptote is that y equals 3x plus 3.